right, so this first says to state the transformations from f of x to g of x. So that's our number one. That's what I want to do first. So let's go ahead and try. What transformations are happening from f of x to g of x? What's happening? Yes. Yes. Now, why is it being compressed? Right. So our original f of x is super skinny, right, by a factor of 3. Then g of x is transforming to be back to the original, back to the parent function. So it is actually getting wider. It's being vertically compressed. By how much? Yes. What else? What else is happening? What is the negative doing? So I'm going from the original f of x being negative to g of x being positive. So it is being, it's still being vertically reflected, yes. Vertically reflected. Then what? Most people got the number 1 right, so if you think you have an answer, you probably do. Yes, so we started at x plus 1, and then we went to x minus 2. So we're actually moving how many units? 3 to the right. Good. So we're translating right 3. And then we're starting at negative 4 and going to 2. Up 6, yes. Anything else happening? I do believe that's it, right? So now comes, so this kind of should have been easy. You shouldn't have had too much struggle on number 1. Number 2 was the harder thing, the thing that we haven't necessarily done yet. However, it is going to appear on your exam, so that's why I wanted to go over it. It says, the function h of x will transform f of x inversely as the function of g of x in the case above. What is the equation of h of x? So what is this number 2 saying is happening here? Yes. Going from f of x to g of x is being inversed to get h of x. So, what does inverse mean? The opposite, right? If I'm thinking of the inverse of something, it's the opposite. Okay? So, what is the opposite of vertically compressed by 1/3? Stretched by 3. The opposite of 1/3 is 3, stretched by 3. What is the opposite thing of being vertically reflected? So if something is vertically reflected, what is the opposite of being vertically reflected? Not being vertically reflected, right? If something is happening, the opposite of it would be for it not to happen, right? So not vertically reflected. Then translate right 3. What's the opposite of that? Left 3. And up 6? Good. Now, are we writing a function of this transformation? Or are we trying to now apply this transformation to get where h of x is? We're trying to apply it to then find out where h of x is. So are we going to apply it to g of x, do you think, or f of x? f of x. You're applying it back to f of x. So f of x is our starting point. We're trying to now vertically stretch by 3. So if we are looking at f of x, it already has a stretch of 3. So how do we make something that's skinny by a factor of 3 skinnier by another factor of 3? We multiply, right? It's skinny by a factor of 3. We then have to make it again skinnier by another factor of 3. So those two factors together create 9. 3 times 3 is 9. Does that make sense? Okay, so we start off with h of x is equal to, we know that our stretch is now 9. Then it says not vertically reflected. So if I'm looking at f of x as my starting point, what sign should I put if I do not want to vertically reflect f of x? I don't want to reflect it from what it already is. So that would be reflecting it. Keep the negative. We want it the same orientation as f of x. We do not want to reflect f of x. So because it has a negative, I need to keep the negative because I don't want to change its orientation. Does that make sense? Okay, so it's -9. Then translate left 3. So from x plus 1, I want to go left 3. So what is that going to create? Yes, x plus 4. And then down 6. We're at -4. I go down 6. Where am I? -10. And I'm done. That's my answer. Are there any questions on this? So all that we did was found the transformation from f of x to g of x, found the opposite of that transformation, and then applied that to f of x to find out where h of x is. So it's kind of like if I was to draw a picture, right? And I put f of x here, and f of x is transformed to g of x. I found this transformation factor, say it's y, right? And then I took that y and applied it in the opposite direction to get where h of x is located. That's all we're doing. Got some glossy eyes, some looking at the board but not really looking at the board. We'll see how it goes.